thanks for staying and thanks for the talk. I think this talk will be a little bit related to the talks we had previously, but this is an example of sometimes we might not, be able to do some causal analysis. So we use some correlation analysis to tackle this problem. But in the end, I will tell you, in reality, sometimes we need to try our best to create a simulation system that we could, provide a better insight. So I am Suri Chen, principal data scientist in PepsiCo. In the beginning, I would like to give you a very quick overview of PepsiCo. I think most of you or some of you might have experienced purchase a bag of Layers or Mountain Dew or Pepsi Zero in one of the platforms, Amazon.com, Instacart. Our team is the engine behind all these orders and operations. We are responsible for managing and delivering over 180 products to more than 30 customers. And our business across sales, supply chain, finance, and of course, marketing. And data science, machine learning with engineering team, we laid a robust foundation for a streamlined and data-driven operations. And this project is one of the very interesting projects we collaborated with our marketing team. As an e-commerce business, our marketing strategy are across central around digital platforms. Take Amazon.com as an example. We have 3 main products. Sponsored search, which is when you search a brand or product, you will see this tag sponsored showing up, and you might see this product in the top of ranking. And we have sponsored brand or banners and display ads. Among all 3 products, we spend almost 85% of spending on the sponsored search. So this is our main channel to reach our consumer. And like many marketers, we are trying to answer this very simple but tricky question. How much sales is actually driven by our marketing investment, right? This question is hard to answer because such data points are usually hard to collect or biased, right? So marketing typically will rely on attributed sales or attributed return. Attributed returns, this metric is usually inflating the actual sales or actual traffic driven by your marketing spending. So we wanted to be able to decompose or to be able to measure the incrementality from our sales. And besides, we also wanted to see what is the different drivers in our business driving our sales. And we wanted to be able to break it down into bucket to bucket and hopefully to optimize our budget allocation and possibly in the future predict our sales under changing scenario. So basically, we wanted to come in from the top with a lot of massive signal and into the down some well-explained waterfall chart. And tackle this problem is similar to answer causal questions. And in the past or in practical, there are 2 types of approach. One is purely rely on historical data, right? You could do some causal inference, causal analysis. You could do some attribution model or building some correlation model like MMM, marketing mix modeling. Or you could collect some new data by launching some randomized experiments, right? Like A/B testing. So you could measure, okay, if I do this, how much sales I get. If I do that, how much sales I get. And in our project, in our efforts, we opt for the MMM approach. But what exactly is MMM? So marketing mix modeling is a statistical technique that can quantify the different impacts of your marketing inputs on sales or other performance metric you wanted to evaluate. So if we put it in a mathematical way, it's basically set up a correlation analysis between your sales or your metrics, target variable, and your marketing variables, your impressions, your spending, and other control variable you wanted to consider. Let's say seasonality, weather, promotions, supply chains, macroeconomics, etc. Right? And we usually build the regression model. We want to fit a regression model or software regression model. And typically, MMM will try to decompose this total sales into two buckets. One is your base sales, which says, without any changing of all the control variable you're thinking or marketing effect you're thinking, what is the actual sales you are expecting? And we have another part is incremental sales, which can be attributed by different drivers. So now the question is why, right? Like we have so many tools, why we finally landed up here? Of course, other tools are really powerful and take randomized experiments as example. It's usually a gold standard if you wanted to answer some causal problems, right? But in practical, there are a lot of constraints. For example, it's almost infeasible for us to launch experiment for each of our 180 products. And sometimes some big brand, you would assume the signal from your campaign might be super weak. Like we might expect only 1 or 2% of the lead, sales lift on a big brand. And which means you need to collect a lot of samples, be able to have some significance tests for your experiment, right? And we also need to think about opportunity cost. If you turn off some of a marketing campaign for a while, you might lose the share during the competitions. And the same issue might happen in potential outcomes analysis. If you think about the data, if you business data based on weekly, and imagine you have 4 years data points, how many data points you have? Maybe just a little bit above 200 data points. So using this small data set to think all this complex scenario, it's really hard to do the potential outcome analysis. So we think building an MMM model is more applicable in our scenario. And I hope I have persuaded you, okay, this is a good direction to go. And then now is our favorite part. I know everyone like math, right? No, kidding. So let's explain about what is our model a little bit, right? As I mentioned again, we wanted to decompose sales into base and incremental. And in our case, we consider base coming from the trend and the seasonality. And the incremental, except for the marketing spending, we also consider the pricing strategy, how we change the price, and some promotions, out of stock, macroeconomics, and some special event like Prime Day or Thanksgiving, Super Bowl. We could have built a linear regression model to model this problem. However, we decided to take one step further. We adapted one of the nonlinear transformation on the marketing spending from a paper proposed by Google in 2017. And let's take a look at how it works. So this is a detail of how we could nonlinear transform the media spending. It actually integrates two common consumer behavior in our modeling. So the first behavior, we call it out-of-stock effect. What does it mean? It says that after the first impression or first clicks, consumer might come back later to execute your actual purchase. So your spending will happen when consumer click your ads, but your return might be observed few days later. So there's a lag between it, right? And the second effect, we call it diminishing returns. It's a concept of that your return on investment is not linearly grows with your spending. They will come to a point of saturations where you spend more, but your return is actually smaller. You might see a minor change. So we use this nonlinear transformation to consider more real-world scenario, which is something that linear model might ignore. And perfect. Now come to the hot topic, hot center of today's topic. And I hope you don't argue, fight with each other if you are standing in different camp. I know usually frequentists and the Bayesian, they don't get along well. I personally used to be very loyal to frequentist approach. Nothing is better than just prepare thousands of data, fit in a model, waiting for hours, and you have some sort of magic black box helping you do all the work. However, since I started to work in the industry, most of the time you are dealing with data just with hundreds of entries, and you have to play some magic, make it work. Now I'm like gradually towards leaning into Bayesian approach. So for anyone who does not have concept of this two approach, here's a brief comparison. But the fundamental difference lies into how you interpret the probability. Right? In the frequentist approach, we assume that your unknown parameters, your coefficient, they are a fixed number. And all these events, observation, they are random variables. So if you are doing the frequentist approach, you are finding this set of parameters that can give you the best prediction of all of your observations, right? So you are finding these optimal combinations. But Bayesian approach assumes that your unknown variables or your parameters, they are random variables. So when you have observations, you are drawing a sample from each of the distribution of your parameters and to see whether it will produce an outcome that is close to your observation. So as you collect more data, we will update the distribution of each of the parameters, and hopefully it will consistently produce something close to your observations. So now we have this two approach. Let's try it, both approach, and to see which one any better, right? So we started with building a frequentist, using a frequentist approach. And as I mentioned in the beginning, it's a nonlinear regression problem. Not like linear regression problem, we have a closed form solutions. In nonlinear regression, we need to use some heuristic algorithms to find the optimal solution. And one of the issues that might happen, well, several issues might happen is, first, it really depends on the initial guess of the parameters, right? Nonlinear surveys might have many different local optimals. You might converge to one of it. So given different initial guess, you might land at a different optimal combination of parameters. And worst case, sometimes it might not even find a solution, or you might not even converge. So what follows are intensive rounds of hyperparameter tuning. And it is not very suitable in our case. And in this example, it's a toy case, but it's similar to how we set up the problems. We could use a curve fit from SciPy optimized module to solve this problem. So now we move on to using Bayesian model. There's an open source package called Lightweight MMN. It's basically it's a framework help you to easily set up MMN analysis by Bayesian regressions. However, in our case, we use JAX and NumPy to build our custom model. And these two packages are great. They give you a faster computational implementation of MCMC sampling. So you make your learning the model faster, basically. And I have to highlight here, one of the important steps of Bayesian regression or Bayesian learning is set up your prior distribution, basically how you assume of your parameter distributed. And I would say this process requires a lot of collaboration with a stakeholder and with a domain expert. So one of the example we tried was using some external data collected from Amazon Marketing Cloud, and we uncovered that 90% of consumers actually converge within 7 days after they first click the ads. So we used this distribution to fit the beta distribution and use it as a prior to the lag effect I just mentioned, like ad stock effect. So if you have a better idea of how your different variable contributes to your model, it will really help you to converge or learning a bit more accurate model. And as a result, our model achieve a pretty good accuracy in terms of predictions. In the reporting area, the average error is around 3%. But more important, we could now visualize how different variables or drivers have influenced our baseline sales. Like we can actually see certain factor increase or decrease sales from the baseline and landing into our observed sales. So now let's come back to our initial motivation or initial questions. What do we want to do? Right? We wanted to identify the gap between attributed and incremental sales, or attributed return and incremental return. So what exactly is attributed returns? Here is an example. If you search 0 Pepsi, you know what you want to buy, right? And in the search result, you will get exactly same product page, one with a sponsor tag, one without. So if you happen to click the first one, you will count it as attributed sales, even though it's actually for your organic demand. You really wanted to buy Pepsi Zero. So, so from our model, our prediction is that, I don't know what is this brand, probably I made that. It's definitely not Pepsi, but one of the brands has 2.60 incremental return on sales, return on spending, and attributed return on spending high at 8.48. And both the incremental ROI and the incremental contribution are almost 1/4 of attributed counterpart, which means more than 70% of reporting metrics are actually organic. So here is a huge room of improvement, right? We have a lot of efficiency we could tackle. And if we look at the next graph, we could leverage the ROI with the actual sales or actual contribution to identify the opportunity. In this bubble chart, the x-axis is an incremental return on spending. The y-axis is an incremental contribution, and the bubble size is the total sales of the brand. Ideally, we would like to see all the bubble concentrate into the upper right side, where is that we are gaining as much as sales from brands that have high ROI. Or at least we wanted the brand all moving towards that direction. Especially this yellow bubble, and you can see here, it has the highest return on investment. However, it seems like we didn't invest enough, so you only have less than 4% of contribution. So it's definitely a brand we could consider differently. And second analysis we did is called due to analysis. Business usually care about year-to-year comparisons. But with this model, we are able to break down the growth or the decrease by buckets. In this example, we see the total sales grew 46% for 2021 to 2022. And if we analyze this 46% of growth, we found that the majority of growth coming from the base sales, the demand, naturally grows. And the inflation, we know like 2022 inflation is crazy, and it seems like it's driving a lot of sales for this particular brand. But besides these two uncontrollable variables, we see that because we are maybe spending more, we get the additional 4% positive sale from sponsor search campaign, and we have 6% positive growth because of our better pricing strategy. However, on the flip side, it seems like we lost 5% of the growth opportunity because of maybe reduction of the promotions. And in the future, we could layer the profitability data to further analyze how we could better, put our promotion strategy to minimize this opportunity lost. And great, now we have our model built, and we have the model put into production. Is that it? Like, we can just sign off the project? Easy? No, of course not. Yeah, so setting up that model, just the very first step of the whole project. And why is that? There's a lot of reason. The first things, especially for this project, is explainability, right? So you don't want to see that out of stock is giving your business a positive sales. You cannot fulfill 100% of your order, but you're still getting more sales, right? It doesn't make sense. You don't want to see negative impact of your sales because you're putting, marketing campaign. At least it's 0%, not negative. So in this case, we need to be very careful to choose how do you scale your features. Usually you would do standardization and moving your feature around, normally distributed around 0, right? But that will bring in negative value of your features. When you fit such a model, you might create the things like out of stock give you a positive impact. So we need to be very creative of how do you and feature engineering your different variables. And the second is outliers. Outliers will impact your trend seasonality estimations. In this case, we're seeing a lot of out of stock happening here and some spike that might not even correlate with some holidays, a random spike. We need to detect them and do some special treatment, either smoothing it out or impute them by better value, right? And we built several outlier detection model to actual effort in the feature engineering step. As the next one is the prior design. As I mentioned in the Bayesian approach, it's very important setting up such a model. Except for the out-of-stock analysis, we are also looking for data to better understand the price elasticity on different products. And hopefully, we could use some product category, right? The different bag size, different brands, different categories might give you different reaction between the price or campaign or sponsor search. So we could build some hierarchical learning to regularize your products, your model behavior by their categorical features. And next one is an interesting discovery in this project. So we know multi-collinearity usually is a big problem if you are trying to fit a regression problem, especially when you're using the frequentist approach. You would say, discover whether you have feature that is correlation with each other and just select one. And in this case, we know that price and inflation, they for sure will have some correlation. But we really wanted to keep both of them. How do we do that? So in our case, we've discovered that using the Bayesian approach is actually helping you to reduce the multi-collinearity effect. So there is a toy case. We use this two-step training. The first steps, we will exclude one of the factors and just feed the model, let's say price and inflation. I will exclude the inflation, just feed the model with just price. And then I will get this number, get the mean fitted by the first model. And I use it as a prior into the second model fitting, which is including both features. And it turns out it can actually help you to learn the model better. So in this case, real value is 2, I think it's pretty small, but the real value is 2, 0.5, and 3 of 3 coefficients. And in the end, we learned 1.95, 0.39, a little bit off, but with there's a confidence level you could look at, and 2.99. But if you look at using the frequentist approach, we see the p-value is super high, which means like we cannot really trust our model. It's not really, giving you something significant. So I think this is another design we need to keep in mind when we are building, MMM. The next, and the next thing I wanted to call out is this hyperparameter training. In the productions, usually you need to have some set of metrics to decide what is your best model. And in this case, just looking at a prediction error is trivial. Like, it doesn't do anything. Of course, it will give you an idea how the model works. However, it doesn't tell you the full picture of how is your coefficient, how is your ROI. So we have to design a set of either business rule-based or other metrics to evaluate the coefficient that we learned in our production environment. And it usually is a iterative process between data science and our stakeholder. So all right, we are coming to the end of this use case, and there are three main takeaways I would like you to take home today. The first one is frequentist approach usually provide you a faster and simple way to learn the data pattern. However, Bayesian approach gives you the flexibility to integrate your prior experience and domain expertise into your modeling efforts. And it usually works better when the data set is smaller. And the second takeaway is the explainability is a key when you're doing such a model, marketing mix modeling. And we could utilize a clever way of efficient engineering to boost the explainability. And last one, this never is a one-time solution. It's going to be an iterative process between different parts of business, and sometimes it's more like art than science. So does this mean we are never going to end this project? Maybe. So call back to for everyone who stayed from last session. You might already agree with me that doing a correlation analysis might not enough to answer a causal problems. So and there's a lot of challenge, like especially for scenario that's never happened in the past. How could we potentially solve these questions, right? So one of the idea is maybe we could build some simulation system by bringing different, more augmented data sets, right? We could create some Markov chain. We could create some transition metric to know how consumer will react to your decision in different way. And you could use simulation system to test how robust your model is. And hopefully, we could launch a sort of experiment or measurement to test your model, to validate whether your hypothesis is correct. So yeah, maybe it will never end, but at least we could get in close there. Yeah, and that's all I have today. Thank you.